Why?
It started. Go ahead.
Okay, good morning, everyone. My name is Dekel Cohen. I will present myself in a second. I would like just to start with a small video. Let's try.
In the vast landscape of global affairs, conflicts persist, touching every corner of the globe. The Council on Foreign Relations Global Conflict Tracker identifies 32 live conflicts worldwide. These vary in intensity and impact and are grouped into three categories: worsening, unchanging, and improving. Among the worsening conflicts are issues in Israel, Palestine, Ukraine, Afghanistan, and violent extremism in Africa's the civil war in Myanmar, the Taiwan dispute, instability in Haiti, the Nagorno-Karabakh conflict, and Sudan's power struggle also feature. Each day, these conflicts evolve, introducing new challenges. It is our shared duty to stay informed, to understand, and to act. Because peace, after all, is the ultimate goal.
Okay, so good morning, everyone. My name is Dekel Cohen. I'm part of the Integrated Defense Solutions in Ribbon. I'm stated in Israel. I'm a telecom network architect in specialization in defense networking. For the last 30 years that I'm in the telecommunication market, over 20 years out of them in military communication networks. I've started with voice and voice over IP, which evolved into unified communications, managed the cellular and wireless access networks and transport and backhaul. And in the end, looking at turnkey communication networks for defense forces, intelligence, and military applications. I'm a master's with education in logistics, engineering, economic, and business administration. And I will try to take you this morning to our last almost 2 years experience with the ongoing conflicts around the world, and I will try to share with you the aspects of these conflicts into the communication networks and their evolution and digitalization during such conflicts. Since this topic is quite large, so it will be probably a little bit high level, and somewhat in time to time I will try to dive into one of the issues more deeply. We do urge you, since we would like to have more sessions like this, at the end of the session we will share a questionnaire to learn from you if there are other topics that you would like us to continue with, and to dig deeper into them, and then to bring you more knowledge and more in-depth discussions. As you have said, there will be a Q&A session in the end. I will try my best to leave time and to answer the questions that are general to everyone, and the ones that will be more specific. We would love to get back to you in the near days and to respond to every question that you have. So let's continue. In Ribbon Defense, we have in general, as the overall ribbon, we have the federal cloud and edge that are bringing all the discussion around unified communications and voice over IP infrastructure in the federal and the defense market, the US, the UK, and other defense forces around the world. With the IP Optical, we have a methodology that is running for the last more than 2 decades of multi-domain network for IP Optical network. And with that, we've generated an integrated solution that is providing the C4I and cyber for the defense and intelligence market. It's also relevant to Homeland Security. To you, who are less familiar with the term C4I, this refers to the entire ICT landscape of the Defense Force, the integration between all the different arms into one shared network in every army or defense force that you will encounter. Obviously, we are providing our core technology, but with that, it's always not enough. So we took and brought the complementary solution and integrate them into our core technologies in order to provide in the end a turnkey engineering and delivery of a project. So we could provide an end-to-end solution or parts of the solution, including the supporting infrastructure, the management and tools required to provide such solution. And since we are talking defense, we are talking also about the cybersecurity suite that is governing everything. When we are looking at the Defense Force communication networks, we are actually preparing ourselves all the time to yesterday's war because we have outcomes of last conflicts, and we are trying to build ourselves to the future, to the next threats. Having said that, we are also looking at digitalization in the digital area, and we are building a concept that is vastly common in the world, that is called multi-domain warfare, that provides air, land, sea, cyberspace, all the domains you can think about as one joint combat that that are sharing the same agenda, the same target, and not only land or air and so on. We are trying to build fire-centric warfare, which is taking parts of different forces and joining them together in order to bring more optimized and accurate mission with advanced aerial protection and robotic systems and accurate firepower in order to save lives and to have a lot of video feeds and big data analysis and intelligence. And these are all nice big words that bring us to the fact that we want to be specific in our defense missions around the world. And this is how we plan when we are in peace times. It's not just broadband. Then we are looking at the fact that on top of the big broadband that we need to bring more mobile networking, while there are fixed locations that require the information with the guaranteed performance required. We need the network to be smart because we cannot maintain it anymore with lots of manpower, because we are always on the stress on the head count that we have in order to manage the technology. And then we want to collaborate with either for a mission or for a drill exercise or any other reason that we need to collaborate in order to get the mission. And what brings us into the rapid adjustment to the environment, because in the end, we are evolving, but our enemies are evolving and digitalizing themselves as well. As you can see from the Ukraine side, that are fighting against drones and hives and precise missiles and UAVs and also classic military platforms that they need to handle toward the terrorist organizations that can use something simple and pure like a paraglider, and to use it with explosives while having mortars as well as light weapons, guerrilla war, and still to have urban fighting and underground fighting against the defense forces, what we like to call asymmetric warfare between the two sides, and we need to adapt ourselves into this scenario. So in reality, we are requiring to pivot while we are in conflict. A nice example would be the Ukrainian Defense Force, which took a DJI drones and connect explosives into them and use them in order to attack tanks, which are classic platforms in order to attack, or the use of drones instead of dogs, canines, in order to explore tunnels for explosives, also threats. The use of civilian that is guiding forces in order to fight terror attacks, or even to protect the country against missiles attack, when you need to understand where the missile is going to hit. If you are targeting the missiles and you need to hit it, where is the debris are going to fall, and then to have the right alert to the civilians in order to protect ourselves, because you don't want to put the entire country into a bomb shelters all the time, because then you are losing most of your economy and your day-to-day life. You need to adapt yourself in order to have command and controls on the field, and still to have all the information and all the communication that is needed in order to keep the mission ongoing. So these are all aspects that we will try to dive deeper into them in order to understand what are the cause and the effect that is doing into the communication networks, and how we have tried with our solutions to provide an answer to. So the network that we have, and anyone that serves the Signal Corps in the military knows that this is the last thing that is interesting the decision makers or the generals in the military, since they are all interested in the next ammunition, the next weapon, the next protection, the next application. But the network is the part that connects everything and actually enables us to run this application, because it's very nice to have a vest camera or a drone with an explosive on it, but if you cannot command it to attack, or you cannot take the decision, you might make a mistake. So you want to sit in, as a general, in a command and control center, a war room, and then still to be able to give the command in order to hurt the target. So we do need the network, just that normally we are striving to explain why it is so needed and why is it required. So let's look at the cause and the outcomes that we have in such changes and pivoting within the network. So first, there is the issue of business continuity. With the new type of warfare that we are encountering today, having using drones or long-range UAVs and precise missiles, so obviously that bases are the target, but the bases that are in target are not just the frontline bases. We are talking about also the back-end bases. We are talking command and control centers, war rooms, and all other bases. If you look at today news, there is a huge discussion in the US around the drones that are flying throughout New Jersey, and no one knows what they are and whom is flying them. And actually, you can see behind your lines, maybe someone that tomorrow can hit you with explosives, and you will not know where it's coming from. But when you do have a warning system and you are in a conflict, it means that you need to handle your bases. It's also your backend that is under fire, so your soldiers, they cannot stay all the time in the base because they have families. And with the defense forces, they are also in a mission to protect their soldiers' families. So the soldiers will be able to fight and will have less caring to the problems back home. So the effect of that is the fact that we need to reduce the workload density. We need to put some of the soldier in one place, some of the soldier in other places. Less relevant soldiers needs to be spread out in order to protect their lives. We need to create geo-redundancy to the war room, so we could have business continuity for the war room, and maybe to enable soldiers and officers to connect the network from remote. So we will be able to continue the work without risking more soldiers' lives. This brings us to Ribbon's unified communication solutions and low-cost video conferencing, because once served in the army, most of the communication is being done either voice or video. The commanders are used to see their subordinates, so video conferencing is somewhat their more preferred communication if it's not a person-to-person discussion. The old times, there was a very expensive video conferencing solutions like we can find in the enterprise conferencing rooms. Today, every cell phone, every computer is a potential video conferencing solution, just like we are doing today with this Microsoft Teams. Just that for us as the civilians, this is very easy because Microsoft Teams is running in the cloud, and the defense force do not enable himself to discuss confidential issues over someone else's cloud. So we need to find solutions for that as well. This is what we are providing with the unified communications in Ribbon. Obviously, that we can connect to private and defense clouds to countries and organizations that have them, but also to private clouds and to cloud-like implementations in smaller scales. In the IP Optical, we do provide flexible sub-networking capabilities, so we will be able to extend one of the booths in the war room and to take it somewhere else, while keep the same communication that the booth in the war room had. So on the desk, so we could be able to have a defragment war room that each booth is sitting in different places. One of the key ways to do so is with communication blueprints in the management platforms and semi-mobile networking. So we will be able to deploy it everywhere and to give communication in near real-time installation. So we are talking minutes to few hours in terms of deployment of a communication booth out of a war room in order to continue the communications. The communication fusion is the fact that if we are talking about putting the targets in the targets list, and to give the people that are controlling UAVs and drones and command and control maybe ships that are attacking and providing firepower from the sea, we need to guide them. We need to give them the right directions where to hit in order to preserve lives of uninvolved people. We need to coordinate these attacks. We need to get the HQ or the war room approval for the attack. And we need to provide for that the right communication infrastructure. So a soldier and also a civilian, in some cases, if it's unplanned event, like we've seen in October 7th, is the fact that we need to give them the ability to communicate. In all times, we had special units that used to go behind the enemy lines and to target with some laser markers where to attack and to guide the actual missiles, and by that to put them in risk. Today it's easier. You have your own coordinates. The missile is a smart missile. It can get its own coordinates as well. But in order to hit very precisely, then you need to differentiate between one window to another in an urban environment. So you want someone to guide you, and this guidance normally is being done either by a picture or a video or a voice. We do see the use of reserve forces, obviously in countries like Israel, that most of the fighting force is dependent on reserves. But also, if you look at the Ukrainians that are taking civilians, train them in Europe, and sending them into the battlefield, you are taking civilians that have civilian tools in their pockets, and they want to use their available technologies without understanding the aspect of cybersecurity or the operationability and the ongoing thought that the military is doing when he's preparing himself in peaceful times. We are trapped in an urban battlefield. We need to adapt ourselves and also underground, and to give all these abilities above and underground. So it provides us a new chain of communications. In one hand, we need call it a simple infantry soldier to be able to communicate with a back office UAV operator. And on the other hand, we need to be able to provide decision making more accurate, because someone in this communication requires to take the decision to fire, because we are all still working under human rights legislation. So we need to preserve uninvolved people out of the fight and not to harm them. We are seeing use of non-secure technologies, as explained beforehand, which means that we must have an adaptive test center to test new technologies on the go. So when we see change in the battlefield, we will be able to test the technologies in order to push them quickly into the fight, and to protect them and to secure them, so they will be able to be used in other places, and not just in a specific, just because a specific soldier or a commander decided to try something. We need to build gateways, entry points between different networks for voice and video feeds, and network stitching points, so we will be able to pass communications between one force to another, in order to create this fusion that was nicely discussed in a lot of defense forums and conferences on how do I take one country's infantry with another country's air force and with a third country navy, and building a joint multi-domain division. While when I'm doing so, we are talking in real time that we need to take one specific soldier to communicate with one Navy vessel and one airplane, and to connect between them. We want to do it in real time or near real time, and not as one of our practices. So we need to build the gateways for that. So we see an involvement of an uninterrupted network. If we had a network for Air Force and Ground Force and Navy and Intelligence, and each one of them was a closed network that they had connecting interfaces between one another, but the connecting interfaces were very protected. The Air Force is frightened from a threat, a cyber threat that will come from a Navy vessel or from a ground force soldier that may be taken into captive and will impose a threat to their network. So they are protecting them. And in the center, having one secured network, where when we are going to a more cloud-oriented network, which each one of them still has its own cloud, still protects its assets, but in reality provides gateway to any type of soldier to either its own cloud or to the other clouds, in order to share and to reach the information that is required on these specific missions. We can give rights and access, and we want our network to be smart and sophisticated. So we are looking at pushing the cloud into the edge of the network, so we could bring more real-time applications and application containers toward the communication sites, and to have still one joint network, but with still small echelons, each one protects its own. The network still needs to be resilient. The network may be attacked because we have communications in our outpost. An unintended explosion or a hit of an accurate or an inaccurate mortar or a missile that hurts your fiber optics cables or any other communication means in your backend. And as well as malfunctions in the network. These are all issues that makes our need for resiliency way better. One of the key aspects is the fact that if we think about civilian communication networks, we are actually talking about networks that need to be optimal in cost versus investment of building the network. So we would like to build the network into the average use of the network with an ability to handle peaks here and there. With the communication of the networks for defense, we actually need to plan our network into the peaks of the usage, because most of the times we do not have chatter in the network. We don't have applications and video feeds that are running. We don't have the reserve forces that are running in the field with all the video feeds that are loading our system. And then we need to maintain ourselves in the peak, but we can try and calculate it. But with IP networking, it's all statistics. We are trying to foresee it in advance, but we cannot do it all the time. So we are looking at, first and foremost, redundancy. You will see that when we are planning our platforms in order to deploy the network, we are looking, in one hand, the small amount of interfaces while keeping the lowest with the lowest footprint that we can. We still look at the redundancy at an element or a platform chassis, so we will have redundancy even in the lowest scale of the bases or the deployments. Actually, one of our unique value propositions is we are in Packet Optical, we are the smallest and still fully redundant element in the market. In the cloud and edge, you would see that we have one element that is serving both voice, data, and other cloud network functions in order to deploy in a one U element our entire capabilities for the networking. You would see that I also will not talk about specific boxes. This is always evolving, and we can get into deeper design criteria and sizes in other sessions. Then our network needs to be self-organized. If it's being in the application, what we like to call ASON, or with the wavelengths, if we are talking about optical networks, we need our network to be able to react into a malfunction in an automatic or semi-automatic ways. Some of the commanders would appreciate knowing how the network will behave in case of a malfunction. Some will understand that they are lacking the manpower, and all they would like is to have the network keep on running, even if they are not knowing where the traffic is going right now. And each of the customer would require something else, but we want to have either automatic or semi-automatic change of the network in order to keep the applications and the traffic running, assuming with zero downtime, zero loss of any traffic whatsoever. Or if would like to be more optimized, some that we lose will be something that we decided in advance that we are willing to lose this traffic. Each commander that is responsible for its communication network in the defense force, when there is a malfunction, the first question would be, okay, what is the operational impact that I have from this malfunction or from this hit? And we need to be able to give them the answer. We need to be able to say, hey, you lost your video feeds to the frontline outpost, or you lost your communication between the Air Force to the Navy because you lost this specific fiber. But they want to know what is the impact, and they want to know that immediately. This is what they need to give to their commanders who do not care about networking whatsoever, but they want the bits to run in the network. We want to be fault tolerant, so when we are loading the network, we will be able to sustain 2 consecutive faults, sometimes even 3 consecutive faults. So we will be able to keep on running even if there are malfunctions in the network. We saw that we need the war rooms to be less centralized. So our network also should be able to be decentralized in order to provide the redundancy and the resiliency that is required. We need to be able to have rapid requirements. So if we lost an entire communication site, we will need to be able to rebuild it or to put something in replace in order to resume the redundancy, or to resume the resiliency, or to resume everything entirely. Obviously, that real-time monitoring is required. We like to say it all the time that we need to have management in order to see all the network elements. In reality, in wartime, when you see your entire map colored in red because there is somewhat of a malfunction, that is influencing another. So if there is a fiber cut, the optical elements will say that they are malfunctions. The IP elements will say that they are malfunction, and the application will say it will be malfunction. So the real-time monitoring is getting now a really important aspect. We need to understand where the malfunction is coming from, and we need to shut the ones that are not interesting. So all monitoring of the network become multi-layer, multi-technology, and we need to differentiate between the malfunction and the shades that they are casting on other layers in the network. And we need to be able to be scalable, because we do not know where we will need the bandwidth, where we will need the applications. You are not choosing the location of your battles. As we started, you can plan, but it doesn't mean that this is where it will happen, and you need to pivot. So you need to be able to scale. We do have in every layer scalability features in order to grow fast with less amount of engineering that is required in general. We would like to react, hopefully, in 0 days to any scalability that is required. In terms of cyber, obviously that we see in today's conflicts unprecedented scale of cyber attacks, and it can be in all levels. It can be attacks on the civilian side. It can be recruitment of internal agents to create a network breach in order to reach the network or to harm the network. And the frontline bases, the outposts that we have, they are at risk of being overtaken by an enemy force, and from that to serve as an attack vector, an attacking point to attack the entire network. So your network can be harmed for specifically one of your real nodes. So we cannot use civilian infrastructure. This is obvious, because the civilian infrastructure is easily can be attacked from remote. Collaborating forces are also imposing threats to each other. One infantry soldier can be used in order to attack the Air Force, and we need to be able to protect one from the other. Frontline bases, as mentioned, are a potential attack vector. So one of the common practices in all the last decades that we are talking about, air gap networking. The military has its own network, which is presumably disconnected from the civilian world. So we need to keep on maintaining that, even if we are trying to use civilian off-the-shelf technologies in order to use them in the battlefield. So think about the idea that I would like to take my hobbyist DJI drone and now communicate its video on a different network, which is not the internet. It's not your cellular that you use to work if you practice it yourself. And we need to see how we bring this video backward. We need to have segmentation and segregation between different echelons, between different forces using the same network, so they will not impose threats to each other. We are using, for an example, in the IP network, hard slicing and differentiation between different forces, while they are capable of using the same network elements. It's not a VPN separation. The nice VPN separation that is offered from time to time is normally equals to no protection. And if it's not a real protection, there is the risk of someone feeling that he is protected. So we prefer even not to use it whatsoever because people may think that they are protected and they are not. So we are building solution for zero trust. We are working with lots of partners around the world for zero trust security with strong authentication, certification, anomaly detection in all the levels. If we are talking at our initial layer 0, layer 1 with encryption and tapping identification to networks segmentations and authentication of elements, users, and other APIs that are served in the network. We are talking about securing while hardening the elements in all levels. So we put cyber in every aspect of what we are doing in the network. We are talking about unprecedented amount of data. We are at the AI era. Everyone are talking AI. There is a lot of analysis that can be done, and this is and we have some examples of using them in the last conflicts, like casualties forensics analysis or video-enabled devices like drones and vast cameras and real-time targeting. And we would like to bring all the information later on for auditing and debriefing because there will be court to someone in the end. And we would like to keep our democracy up and running. So we see an exponential growth to bandwidth with centralized computing power, which makes a lot of collusion points to the traffic. We're talking about low latency and raw data that we need to the AI. So we need to reduce the cost per bit and to have a capacity growth over the existing infrastructure, being fibers or air, because the deployment of new infrastructure will cost us a lot of time, and this is not real-time growth. I'm running a little bit forward due to time in order to leave time for questions. Some of the applications and networks. So one of the big applications that are hitting around the world today and doing a lot of mess, we are talking about air defense. No one is fully protected unless it has several protection layers, again, different types of air threats like missiles and mortars and UAVs and so on. In terms of networking, we are talking about each one of them is a network element that needs to communicate between one to another. Some of them are connected wireless, some of them are connected by fibers because they are semi-mobile or non-mobile or as needed. In order to connect them into the targeting system, the projection where the missile will hit, and to distribute alarms to the civilians or to the relevant bases. So we are talking about a very low latency application, unexpected deployments because we are always optimizing the location in order to use the radars and to take the polygons and make them smaller and smaller and to connect them in real time. We have a design for that for reception sites with MPLS-TP layer 2 VPNs in order to have very quick redundancy and growth to this network and point and click service provisioning. So such network could be built and could be designed in real time when the threat is being changed from attacks from the south to attacks to the north and so on in the network. With the mass data collection that we saw, we have targeting, location mapping. We are using a cloud infrastructure when it's possible in order to use AI capabilities in zero time. And so we need to bring them the data. So we are talking about building secured cloud infrastructure. We can today deploy data center with a complete data center with a week time if the infrastructure exists in terms of civil. We are talking about low-cost flexible optical network, so we will have a very high capacity and low footprint capabilities, because in the end, everything that we are building should be missile protected, because this is the defense force. So we cannot build it overground, but only underground and protected. So the footprint is a critical issue, and we need to maintain it very low. We've built an integrated unified communication concept that is providing capabilities to deploy telephony with voice over IP, with VC, which will be secured. We have call centers in order to serve the army itself, connecting 4G, 5G, private networking, voice, and having deployable command and control centers to the network, with connecting to what the unified communication technologies are going into a more centralized and cloud-based architectures, meaning that they have to integrate to our legacy data center segment, which the voice in this aspect impose threat to the standard data center with the Outlook servers and the domain controllers and so on, while maintaining our existing infrastructure and migrating it on a graduated manner, because the replacement of the phones, the lines, and so on takes quite a lot of time. We've seen coalition forces that in need to operate together and to target different threats, and the mission are carried together, and they are ad hoc, maybe coalitions in multi-domain. We've built a concept for open network with flexible sub-networking and network stitching between point of presence of the network, so coalition forces can share information together in order to target and work together. Until today, when you are looking at coalition, someone is still coming with a communication node to a coalition partner's command and control, and opening a stationary booth or a desk, and being a liaison between the forces. We are trying to bring more real-time integration between coalition forces. So this is how it looks. We have slices within a network that we are able to stitch upon needs. So you can see on the right side that then with the slicing capabilities, we are building to take one share of a network in one and share it with the other. And then with the physical connectivity between the points of presence, we can create stitching in different layers of the network that in reality creates slices of networks of joint applications that are running between shared or collaborating networks to provide one of the applications that is needed in order to provide maybe a cloud-native application or a software-defined and open network. So how do we look at the future? So in the future, we would like to see more network automations to handle complexity, to have faster from requirements to operationality capabilities, with an ongoing resource optimization, so we will never find ourselves in a peak of a use of a network, and to have a self-healing network as much as we can. We are looking at network flexibility in our capabilities in order to provide the optimal technology in every layer to reduce the deployment time, to generate a bandwidth as a service to each of the applications that are being served in the network so it can grow and shrink upon need against other, and to provide any-to-any unified communications, being either voice, data, video that is being shared between anyone that is allowed to connect to the network with simple approach. We do look ourselves as advocates of openness. So we are looking at openness in a multi-layer technology, multi-layer and multi-technology with flexible connectivity to other systems, and also to enable to connect other in our southbound interface, other elements that are already exist in the networks, being routers, being optical users, voice, whatever we are talking about using the investment that is already exist with network interconnects and open technologies. Two interesting examples that I'm sharing here. One is with a need-based approach. We look at our customers as partners all the time. So if there is a need, we are even willing in the right discussion to develop the right node that will serve them in their type of deployment, or to integrate STAM engineering in order to have them deploy their communication node in the field. As you can see on the right, this is our newly engineered and vastly used in the last conflict mobile communication node that is being deployed as resilient nodes, or where we need to have deployed forces. So we at Ribbon, we are unfortunate to say that we are battle-proven. We have a lot of experience gathered over the last years. We would like to keep peace, but we need to prepare ourselves all the time to the changes in the battlefield. We are here and we will continue with product support and upgrades. So everything that we are looking for the defense forces for end-to-end ILS, integrated logistics support throughout the needs. We are worldwide. We have offices and people and partners around the globe. So if you have an international partner or international need, we are here to support you. We are under the hood. You can find us a lot of times under the hood of other players. You don't need to put our faces in the front. You can use us under your hood as well. We have experts in every field of expertise that you need, in every type of arm that you need to discuss a battle-proven communication needs. And obviously we are all in. We've been there, we've done that. We look ourselves as still as soldiers in the Ribbon defense markets, and we are still behave the same. With that, I've managed to stay on time. So I would like to thank you, and Yoav, if there are questions, I would like to answer.
Beautiful, Dekel. Thank you so much. You're really on time. We have 4 minutes. I haven't seen any question on the chat, but if anyone has anything right now, you can unmute yourself and present the question for Dekel. You can write it. You can unmute and speak to Dekel. If not, I will also in the chat. I'm placing Dekel's email, so you can of course contact him directly with any question on or need. So let's give it another half a minute just to see if anyone has anything. I see people clapping, which means that you've done a good job. Another clapping. Good, Dekel. Okay, good. So I think that it was all people understood, and again, you're available for them. I also placed our resources for partners. As always, you have the LinkedIn, you have the newsletter, so you can always keep up with what we're doing. Thank you so much, everyone, for joining. Thank you, Dekel, and
Thanks a lot.
yeah, see you on our next webinar. Goodbye.
Bye.